Okay, um, probability review part one. This is for two-way tables. For flights from a particular airport in January, there's a 40% chance of a flight being delayed because of icy weather. If a flight is delayed because of icy weather, there's a 20% chance that the flight will also be delayed because of a mechanical problem. If the flight is not delayed because of icy weather, there's 10% chance they'll be delayed because of a mechanical problem. Answer the following questions, assuming that one flight is selected at random from the airport in January. So when I look at this, first off, if I see three numbers, it's generally going to be a two-way table or something that's going to be can be solved, or two-way table will help you organize it. But to verify that, I need to look to see if I have two variables. In this case, I do. I have ice delay or ice weather or ice delay. And this is also video 5. I should have said that. And I also have mechanical delay. So I have two variables. I have two variables. I was like, you know what? Anytime I have two of something, I need a two-way table or a sample space to organize it. So I'm going to go at it that way. So I'm going to look at this. I'm going to go ahead and set up my window. And I know I haven't identified which variable goes where yet, but I will do that here in a moment. And I usually don't take time to make these very pretty. I guess I should for the video, but here we go. We have summing to 1. So I'm going to reread this thing real quickly. And I'm looking for a number that is only associated with one variable. So for flights from a particular airport in January, there's a 40% chance of a flight being delayed because of icy weather. That appears to be one variable. It appears to be ice delay. So this appears to be the one associated with one variable, and it appears to be associated with an ice delay. So I'm going to put an ID, ice delay. Okay. If a flight is delayed because of, I have a condition. So this one's if a flight is delayed because of icy weather, there's a 20%. So this number 20% has two variables. I know this because it has delayed because of ice and mechanical. As soon as I put a condition on it, it's going to be two variables. If a flight is not delayed, once again, a condition. So this is also going to be associated with two variables. So I found my number associated with one variable, and it's 40%. And I'm going to always put that number right here every single time. And I'm going to go, well, that makes this 60%. Well, what was this? This was an ID or an ice delay. So this would be, no ice delay. And I try to make these really simple. So ice delay, no ice delay. And then I'm going to take those numbers and I'm going to write them fairly small and bring them just straight up in the column. Just like that. All right. So keep reading. If a flight is delayed because of icy weather, there's a 20% chance it'll be delayed because of mechanical. Ice weather, so ice delay, and this is going to now be 0.20. This will be my mechanical delay, and this will be 1 minus 0.2, which is 0.80. You're going to be always going to be one, whatever it is, these things have to sum to one whole, and they do. So I can go ahead and multiply these. 0.4 times 0.2 is 0.08, and 0.4 times 0.8 is 0.32. Now, this number and this number need to sum to that, and they do, so I probably did it right. All right. Next thing, if a flight is not delayed, so not delayed because of ice, there's a 10% chance that it will be delayed because of mechanical. Okay, so not ice, but a mechanical is 10%, so this is 0.1. Well, 1 minus 0.1 is 0.9. So these two sum to one whole. All right, which they have to. I multiply these out and I get 0.06. And I multiply these two out and I get 0.54. And 0.06 and 0.54 sum up here, and that looks pretty good. I add these two across and I get 0.14. And I add these two across and I get 0.86. and this sums up to 1 whole. So I'm feeling pretty good about the way this is working right now. All right. So the first thing is, what's the probability that the flight is delayed because of a mechanical delay? Well, the probability of a mechanical delay happens to be 0.14. We have it right there. So the probability of an MD or mechanical delay equals 0.14. So that was easy. Now that we have the table, what's the probability flight does not have a mechanical delay? So no mechanical delay. So we're looking on this row right here. Does not have, but does have an ice delay. Oh, no mechanical has it, but ice, so that's 0.32. Because basically what they're saying is probability of NMD intersect ID. In other words, not a mechanical, but it has this. Now they use the word but as opposed to and, but it's still a conjunction, so it's combining them together. What's the probability it has both delays? So we want the probability of a mechanical delay, probability of a mechanical delay and an ice delay. Well, mechanical delay, ice delay, where do they intersect? They intersect at 0.08. So this is 0.08. I guess I should have put this closer right here. What's the probability that a flight has an ice delay given that it did not have a mechanical? Well, given's always in the denominator. So remember, it's always going to be intersection over given. So not a mechanical, given not a mechanical is going to be 0.86. But the intersection of ice delay is at 0.32. So 0.32 over 0.86. And let's go ahead and figure that out. 0.32 divided by 0.86 equals 0.3720. I truncated. And what's the probability to have at least one of the two types? So here's where I'm going to have to go. Probability of A union the probability of B equals the probability of A plus the probability of B minus the probability of A and B. All right. So what's the probability of an ice delay? Well, probability of an ice delay is 0.40. And while we're looking at it, what's the probability of a mechanical delay? Probability of mechanical delay is 0.14. I'm going to go ahead and circle those two because there's going to be something that pops out to us real quickly. So here was the ice delay at 40%. Here is the mechanical delay. And I noticed something. I noticed that the 0.08, which is the intersection, got circled twice. Because it got circled twice, it got counted twice, which is why, according to the formula, I have to subtract it out. So when I do that, I end up getting 0.4 plus the 0.14 minus the 0.08. And that ends up being probability of having at least one equals 0.46. All right, there that is. And here's the table. I hope this helped. Thank you.